The next chapter, Pythagoras' Theorem. Now, Pythagoras was a Greek mathematician and philosopher who lived 500 BC and spent his life in exploration and learning facts about mathematics. In fact, Pythagoras was amongst the first people who proposed that the earth was actually spherical in shape and not flat as so many people believed. In those days, it was known that if you had two sides of a triangle measuring 3 units by 4 units, the hypotenuse always measured 5 units. Interestingly, 3 squared plus 4 squared is equal to 5 squared. Pythagoras very quickly realized that these apply to all right-angled triangles, irrespective of the dimensions. He formulated what we now name after himself, the Pythagoras Theorem. Pythagoras noted that in a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the 2 shorter sides. So for a general right-angled triangle, C squared is equal to A squared plus B squared. This is the Pythagoras theorem, and you have probably known it right from your primary school. So, do you believe that this is true, or do you know that it is true? There is a difference. You see, true mathematical knowledge comes when you understand why something is true. In mathematics, there is no hoping and believing and wishing, but there is lots of proving to do. A proof is a logical argument showing that something is true. Let us prove the Pythagoras theorem. Let us pick a random triangle and label it A, B, and C. C is the hypotenuse. In many textbooks, the authors use H for hypotenuse. I'm trying to avoid that because later H is used for height and it sort of introduces confusion. So let's stick to C. Next, we make 4 copies of this triangle. We will now arrange these 4 triangles to form a square. But first, we label the angles in these triangles because this will help us later. We call the small angles alpha and the larger ones beta. The largest angle is the right angle, which is equal to 90 degrees. One more thing, the angles in a triangle add up to 180 degrees, and so alpha plus beta plus 90 degrees is equal to 180 degrees. If you subtract 90 degrees from both sides, you get alpha plus beta is equal to 90 degrees. Another way of saying this is that alpha and beta are complementary angles. Let's begin by arranging 2 triangles so that these 2 sides form a straight line. This means that this is a 180 degrees angle, and since alpha plus beta is equal to 90 degrees, this angle must be a right angle. Next, arrange the 3rd triangle so that we have a straight side here. Again, since alpha plus beta is equal to 90 degrees, this is also a right angle. And using the same logic, we can put the 4th triangle here to complete the square. The lengths of the sides of this square are A plus B, and so the area of the big square is equal to A plus B squared. There's another way of finding the area of this square. We can add up the area of the 4 triangles and the small square in the middle. Remember, the area of one triangle is equal to a half base times height, and so the area of one triangle is equal to a half A times B. The area of the small square is equal to C squared. So if we add up the area of the 4 triangles and the small square, we get a half A times B plus 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 C squared. Collecting the like terms, this is equal to 2AB plus C squared. Right. Now, we computed the area of this square in 2 different ways. and both ways should give us the same answer because they measure the size of the same square. And so a plus b squared should be equal to 2ab plus c squared. If you expand the left side, you get a squared plus 2ab plus b squared, and this should be equal to 2ab plus c squared. 2ab is common on both sides, and so we can subtract it out, which leaves us with a squared plus b squared is equal to c squared, and this is the Pythagoras theorem. So it is true. There is a Latin phrase used to say you are finished with the maths proof, quod erat demonstrandum. This means which was to be demonstrated. You can shorten it as QED. It is a nice way to big up yourself for understanding why something is what it is. Right? Yeah. Let us do 2 examples in application of Pythagoras theorem. First example, calculate the length PR in this triangle. This is a right angled triangle, and so PR squared, the hypotenuse, is equal to PQ squared plus QR squared, which is equal to 9 squared plus 12 squared, that is 81 plus 144, and PR is equal to 15 centimeters. Second and last example, the length of the diagonal of a square is 10 centimeters. Calculate the length of the sides to 3 decimal places. Now, this is a square, all sides are equal. 2 sides and the diagonal will form a right angled triangle. And so L squared plus L squared is equal to 10 squared. 2L squared is equal to 100. L squared is equal to 50. And L is equal to 7.071 centimeters.
And so the biggest challenge is not falling behind, and the strategy is do whatever needs to be done so you don't fall behind. Seek help wherever you can find it, from students, from student help centers, from the teacher, from the teaching assistant, wherever you can get it. Because if you fall behind, it's like you're missing a floor in the building, you're missing a brick in the wall, and you just can't build the second floor without a good understanding of the first floor. It applies course to course, it applies class to class. Miss a class, 1 class, maybe that's fine. Miss 2 or 3 for whatever reason, the rest of they're speaking a foreign language for you, and you just have to make it up, or going to class has no point. If you don't go to class, it just gets worse. It snowballs, and once it starts going downhill, you're in trouble.